Welcome you all to our last presentation called Small Apps, Big Effect. My name is Tobias Vonesch. I'm a technical sales engineer and AWS consultant at Copit. I have a bachelor's degree in computer science. I'm 5 times AWS certified. I know a thing or two about Kubernetes, and I'm part of the AWS Community Builder program. Today I'm gonna present a bit about ECS. It's one of my favorite services, and I think it's massively underrated. I try to keep it as entertaining as possible, but after Luca, I think he set the bar quite high. So let's jump right in. What is ECS? ECS stands for Elastic Container Service. In ECS, we have 2 main resources. We have tasks and services. So tasks are similar to jobs in Kubernetes, and services are similar to pods in Kubernetes. So tasks are short-run containers, and services are long-lived containers. We can launch containers on all different sorts of infrastructure, be that EC2 instances. We can use Fargate or even Fargate Spot if we can live with the limitations that Spot brings us. ECS is capable of auto-scaling. We can mount EBS and EFS volumes very easily into our containers. We can even run containers on-premise or basically anywhere. I mean, the extension is called ECS Anywhere, and it does what it's called. We do have service discovery if we need a service mesh. We profit of all the AWS security features, EIM roles, etc. It's very well integrated with all the AWS monitoring tools like CloudWatch, etc. It blends perfectly with ECR and much, much more. So, who of you is using ECS or has used ECS in the past? Okay, well, a few, yeah. I'm a bit disappointed if not all the Copit hands go up, so Roman, maybe we have to talk later. But yeah, the other question, who has used Kubernetes before? Okay, but there are more hands up for Kubernetes. So what are the differences? Peter has already mentioned that a bit, that they are very similar, but yeah, what are the differences? So ECS, also as Luca said, has many pros but also cons. It's a natively integrated to AWS. It's very simple to learn. One of the biggest benefits, there are no control plane costs. So just the usage of ECS is free. You just pay for the workload or the tasks, the compute there. You can deploy blazingly fast, and you have a very good built-in load balancing with ALB. The cons, yeah, the ECS configuration is not portable. So if you build up ECS clusters, you can't just take them and go to Google or Azure or on-prem. Maybe an AI helps you, like if you give your JSON files to an AI, maybe it can translate that for you. But yeah, generally it's not portable. There is a limited ecosystem, like we have less tools. There's no Argo CD, for example, or Crossplane. And with that, also fewer third-party integrations, so no high-end networking technology like Cilium or Istio or things like that. And yeah, there's a limited support for complex stateful applications. Now, if you look at Kubernetes, a lot of the pros become cons, and a lot of cons become pros, right? So it is the industry standard, and EKS, which is the AWS flavor of Kubernetes, is based on the latest upstream version of the open source Kubernetes. There is a massive ecosystem, very advanced networking capabilities, and yeah, you can do very sophisticated workflow orchestration things. On the contrary, well, there's a very steep learning curve, and there's a lot of operational complexity in managing a Kubernetes cluster. It's also more expensive just by default because EKS control plane costs around $70 per month. Now, that sounds like a lot. If we would go like deeper into the technicalities, what's all required for this magnificent service to work, it's quite understandable how this price comes together. But yeah, ECS, the control plane, is free. Here it's by default just 70 a month without the compute. And it's over-engineered for simple containerized applications. Now with the introduction of ECS Auto Mode, this has become massively easier, but still, it's if you just run a WordPress or I don't know, any small containerized workload, it might be too much. So Kubernetes, it's a bit like this. This is a Mercedes AMG G63 SUV, 2025 edition. It has around more than 500 brake horsepower. It accelerates to 100 in about 4.4 seconds. It's also 2.5 tons heavy, and it's very, very expensive. But I think we can all agree it's high-end German engineering. Like it's a fantastic car. And the funny thing in Switzerland is you see a lot of these on Swiss roads, right? And in the Swiss IT scene, we see a lot of EKS or Kubernetes as well. It's just because we can, because we like it. We admire the power that comes with it. But I think we can also agree that for a lot of things, for example, the streets of Zurich, it's a bit over-engineered. So ECS is a bit more like this. This is a car of the car sharing association I'm a member of, and an electric car. And for the most tasks that you need a car for, this is perfectly fine. It's much cheaper. It's shared. It's highly available, because when this is not available, this specific car, I can take another car. This association has many cars. But of course, it's less sexy, it's less powerful, it's less, well, in this case, it's also German engineering, but you get my point. I get my point. But important to say is that at Copit we love both, and we love them equally, and we try to select the right technology for the right customer. So if you are in an environment where you have high needs for networking, for example, and you need Cilium, or any more complex enterprise application, then of course we love doing Kubernetes with you. But if you're just like a startup or an SMB or anyone else, then have a look at ECS. It might be enough. So one thing we quite often hear is, ECS, but vendor lock-in. One smart thing I once heard, and I think this is very true, there is no such thing as vendor lock-in. There is only cost of moving away. I have here a lot of different Kubernetes specific terms, or like levels. And when we say that Kubernetes, it's more portable, it's interchangeable, it's to keep your Kubernetes stack fully agnostic is basically impractical. And if you change one of these components with another one, there is cost of moving away. Like if you switch from Helm to customizations, you're rewriting resources. If you use Argo CD or Flux CD, you're rewriting resources. The same for the networking. Even if you change your flavor of Kubernetes, like if you use Red Hat OpenShift or EKS, AKS, in the end, when you're moving from one to the other, you are rewriting resources. So with ECS, yes, the ECS configuration might not run on Google, for example, but we still have the abstraction layer containers. And as long as you don't do complex things in networking or anything else, then that's enough. So a bit about the operation types of ECS. The first thing, and this is what Petter was explaining before, and the easiest operation type is Fargate. With Fargate, we can create an ECS cluster and write a task definition. And in this task definition, we say that this task should run on Fargate, and then we just throw it at it, maybe say in which network it should run, but throw it at it, and AWS does the rest. And this also for a quite attractive price. So if you have a small web application, for example, that can live with a quarter of a CPU, half a gig of RAM, we're talking around $10 a month. One consideration that you should do, though, I wouldn't build a microservice architecture with Fargate, because even though this is super cheap in even over a month, if you have like one task, if we just scale to 3 services, then yeah, it's very simple math, right? You end up with $30. And just by switching to an EC2 instance, for example, with 2 vCPU, 2 gigabytes of RAM, you can already save a third of the costs. Fargate is especially cool if you are running timed tasks that, for example, can't run on Lambda, because with Lambda, where you just run your code, you have the limitation of 15 minutes, and the Fargate task runs as long as you want it. Another cool thing in ECS operation is the placement and the placement strategies. So even though ECS is a much smaller service, we can still have a big influence on where our containers should run. So by default, there are 3 placement strategies: bin pack, random, and spread. So if we require that, we can, for example, say, okay, I need for my SLA, I need that half of my containers is running on a separate EC2 instance in another availability zone. So this would be one thing we could influence it. By default, it's using bin pack. Bin pack basically means it's packing the containers on the instances where there's space left. So it tries to be as dense as possible. And then there's also random, where it just places them where they fit without any optimization. We can also, in our task definitions, set placement constraints. So for example, if you have tasks that should only run on certain operating systems, on certain compute types, in a certain VPC or a certain availability zone, we can set placement constraints. We can also set placement constraints, right? And lastly, one thing I think is very, very cool, it's quite a new feature, is EC2 managed instances for ECS. So what this does is basically EKS auto mode or EKS with Carpenter, which means that we have our task definitions and we just throw them at ECS, and AWS in the background is provisioning the best suited instances for the workload we're providing. We'll see that in just a second, but what you can see here, it doesn't matter, for example, if I have a lot of containers that are x86, and then all of a sudden I throw an ARM image at it, it doesn't matter. Like if it's in the container definition, AWS will spin up the right EC2 instance for me. And all these managed instances run with BottleRocket as an operating system, which is also very cool. BottleRocket is an operating system developed by AWS, and it's very similar to I don't know, Talos, if you maybe have heard of it. Basically, it's an operating system that purely contains what's absolutely necessary to run the containers. And with that, the attack vector is minimized to a minimum. Because even if someone gets access to your EC2 instance, there is not a lot of pre-installed binaries to like interfere or use to get to your containers or your data or your operation. And also quite a new feature, ECS supports native rolling updates, blue-green deployments, linear deployments and canary deployments. And if I'm not mistaken, then that's already 2 deployment types more than Kubernetes natively supports without Argo CD or any other GitOps tool. Cool. Just really quick things we at Copit run on ECS. We already heard the DIT where we launch tasks. One example where we used ECS was during the AWS Summit for our game. It was called Copit Quest. Quite cool. The author sits there if you have any questions about Symfony or PHP. It's a very simple application, and as you can see, it's a few resources, and it's really not much more. There were 2 Fargate tasks, an Nginx server, and then a monolith behind it. They were communicating, and yeah, very simple application. Another thing we do quite often we do regularly for customers is using SFTP Go. It's a very cool open source project which allows you to hook in different data storages such as S3 and provide a nice user interface. And this is also very cool because in ECS each task has a task role which we can attach, and then if the container is capable to communicate with S3, for example, then we can steer access to the S3 bucket just with EIM roles. So that's very neat and very handy. And now I would like to go into my quick demo, and I hope that the demo gods are with me. What I prepared here is a small ECS cluster. We can see we have 2 services running. One is called Nginx, one is called Ubuntu. And the first thing I would like to show here is also a feature that is not that old, but let's say something fails with your task and you quickly want to rebug it. Then you can go into the AWS console. You can select the failing task, and we can click here on Connect. And if the demo gods are happy with how I behave today, they will let us connect into the container. So to prove that, I can show you. We are here in the Ubuntu container, which is great. So if something fails, we can quickly debug it. This is a very nice feature in ECS. So let me quickly switch into the other service, which is called Nginx. Here we can see we have 1 task running. We have an application load balancer in front of it. Here is the task. And now if I switch to the EC2 instances page, you can see we have 1 EC2 instance here of type C7A. So that's an AMD instance. This is the repository, the tofu code that I use to provision this cluster. And let us do something fun and scale this up to, I don't know, 30 instances. So if I now run tofu apply, in the meanwhile, I can show you a bit. So this is the service definition for the Nginx service. And here we refer to the task definition that was also mentioned before. Here we say which container do we want to use, like the networking, what are the ports. We define the task role that I just said before, where we could attach rights, permissions to this container, some networking capabilities, and in our case here, a hello world command that is then hopefully displayed on the web server. Okay, let me quickly go back here. And as you can see, 30 instances of these containers, they need a lot of compute. So what AWS is doing here in the background, it's ramping up our instances. And it's doing this in a best effort manner. If you let it run for longer afterwards, it will try to optimize it again. But this can take some time. Let's have a look back here in the task window so we can see here the 30 tasks are coming. And let me quickly switch to the load balancer. Also, I just realized 30 tasks might have been a bit optimistic, but think big, that's a motto of mine. We can see now here we're randomly on one of the containers. So let's wait for a bit. Perfect. I can show you here in the capacity provider. So every cluster has a capacity provider, which is like the description of the compute capacity that we would like ECS to pick for us. In here, we have a role attached that enables ECS to provision EC2 instances for us. And here we can name our preferences. Also, we can say, for example, which instance generation do we want. I set this to current, which is also the reason why we have C6 or C7 instances. You can also set them to older instances. You can also enable different CPU manufacturers like Intel, AMD, or Amazon Web Services, which is important if you want to use ARM CPUs. And let me quickly switch in here. Yeah, so all the 30 tasks are running. Now, what happens if we go in here and we change, maybe go down to 3, from blue to green? Because I prepared here a second task definition, which I called Nginx green. Exact same task definition, except here I'm changing the color to green. And to speed things up a bit, because I think the pizza already arrived, I'm also going to deploy this task definition, which is launching the same Nginx container, but this time with the constraint that I want to run it on an ARM instance. So let me quickly go into the, that's Ubuntu, I'm sorry, in here. This, okay. And let's apply that. And now we should see here how it starts to deactivate all the not needed instances, right? Because we scaled down. It might take a bit longer until they are disappearing in here. But what we can see here is that here we now have a C6G instance, which stands for Graviton, which is an AWS chip, so not an AMD chip, but a Graviton chip, which is ARM-based. And if I go into the tasks, the services, and I see here we are waiting for these 3 tasks. and they should appear any second once this ARM-based chip is available. In the meantime, maybe let's go in here and okay. Now you can see we have the Blue deployment and we have the ARM deployment, and the AWS load balancer is now switching between them, whichever it picks next. And if we would let it run a bit longer, then we would all of a sudden get green and red deployments, because that's what we changed as well. Or did I? Let me quickly check. Yeah. I guess it's now first descaling before it will change the image in a rolling update. So that's on me. I'm very sorry. I shouldn't have been so optimistic with 60 tasks. But as you can see, if AWS is good at one thing, then it's scaling. And with that, that was my presentation. And I hope that you will use ECS far more often in the future. It's a great service. If you have questions, don't hesitate, come to us. And with that, we're also at the end of our meetup. And give me one more second to go through the commercials. I said Kiro Hackathon, would be very cool to see you there. On our Copit YouTube channel, you find all the talks of this year as well as the talks from today. Please join our LinkedIn group. Another thing here in the middle, we are still looking for a senior Kubernetes engineer. So if you're very good with Kubernetes, then please come to us, talk with us, apply. We are not desperately looking for people, but we are looking for a Kubernetes engineer. And please fill out the post-event survey. And for all the people who do that, you will get a book from us. If you haven't received one at the AWS Summit, now is your chance. If you already have one, please still fill out the survey. Then you already have a great Christmas present for all your friends and family. It's about AWS cloud projects written by Ivo Pinto, an ex-Amazonian who's now, I think, doing something with AI, like everyone nowadays. And yeah, let's have pizza and beer outside. Thank you for your participation, and we hope to see you on one of our next meetups. Thank you.